What's that? Okay, good. Let's go ahead and get started. I know I'm between you guys and Beer 30 today, so I want to go ahead and get started on this presentation. So my name's David Hines. I'm the Vice President of Architecture and Engineering at TierPoint. Today we're going to be talking about ransomware and take action and keep your money. I think everybody who's been paying attention today, there's been quite a bit of conversation around ransomware and using Zerto specifically as a solution to help mitigate ransomware. Again, let's get started. So I'm going to kind of stand down here with you guys, kind of smaller group, so I figure we can be a little more interactive. Just somebody, what do you think the primary cause of downtime is for organizations? Human failure, that's good. Internet, yeah. So system failure, right? System failure? Facebook, right. I've been in this industry for about 20 years. I can tell you when I started, this was the primary cause of downtime that we were concerned about, right? So I'm from North Carolina. I don't know if we have anybody else from North Carolina here. There you go. So hurricanes are a big concern for us. Again, immature, kind of small IT company, this is what we were thinking. The reality is, whoever said internet, equipment failure is pretty much what I would align with the internet there, is 46% of unplanned downtime. Man-made, human error, definitely a big component. But the reality is today that cybercrime is an ever-growing kind of problem as far as the creation of unplanned downtime, right? So, one of the interesting things as I was going through or working and putting this together is I honestly had not realized how quickly this problem has grown. And really specifically because cybercrime has morphed from a situation where it's related mostly to data theft and more into a situation where it's a data loss or a data prevention sort of situation, right? So we're all familiar with DDoS attacks. They're more point in time, right? The reality is today with malware and ransomware specifically, these nefarious individuals are locking your data and preventing that access to that data, sometimes indefinitely regardless of if you pay for this ransom or not, right? So as you can see, Radware Network was looking at what are the biggest security threats in 2018. You can see that ransom is now at the top of that list. So who can mention just off the top of their head in like a most kind of known ransomware event that's been in the news today? Atlanta, city of Atlanta. In fact, so I think it was March 22nd. Or no, I'm sorry. City of Atlanta was another one. I thought that's what you said.
I remember hearing about a hospital too.
Yeah, I can't think of the hospital.
They just go right out and pay.
Right, that is true. That is true. And in fact, so with respect to the city of Atlanta, I think it was March 22nd, 23rd when the event occurred. They're still dealing with that event today, right? So this is an increasing problem. Right? And you can see from a cost perspective, the incentive to accelerate this problem is there for the hacking community, right? If you look at the cost to businesses, $8 trillion, right, over the next 5 years. I actually think that's underestimated based on some of the other articles that I've been reading in this and the cost to business over the last year. So again, and as you can see, the ransomware attacks have really ticked up with respect to their malicious emails and their targeting campaigns as far as trying to get into your systems and your network to encrypt your data and then start to basically ask you to pay them in Bitcoin, Litecoin, Ethereum, whatever the currency of the day is for that particular group. So the evolution of ransomware. So ransomware is not new. I think it's become much more prevalent, clearly, based on some of the statistics that we've seen. But it started, I think, some of the earlier signs of this are 2010, 2011, 2012, again, very targeted, very individual based, right? Typically the threat was the malicious email, the user executes the attachment, it encrypts their local drives, their local system. That's bad, but it's not catastrophic, right? And it's very localized in its damage. So the evolution of ransomware is the self-propagating aspect of this software, right? So last year, I'm sure everybody's familiar with WannaCry, NotPetya, and the like. These took advantage of vulnerabilities in software that was not patched, unfortunately, and were able to self-propagate through the networks of the individuals or the organizations that were infected. Who is familiar with Eternal Blue? Right, it's a couple of people in the back. So Eternal Blue was really the threat vector for WannaCry or NotPetya. And this was a backdoor in SMB version 1, CIFS protocol, if you will, that had been used by the NSA very effectively for many years. It was leaked by a hacking group in early 2017, and then it was subsequently picked up by the various ransomware creators and said, hey, we can now use a worm type technology to spread this through an organization's network, right? So instead of it being this localized problem, now we've got a situation where entire corporate networks have been encrypted. And on average, which is really interesting to me, they were only asking for about $300 in Bitcoin per instance of encryption. But thousands upon thousands upon thousands of systems were infected and subsequently locked by this WannaCry and NotPetya virus, if you will. The other thing that really changed the game is that it became a business model, right? I mean, one is that we can use Bitcoin now to make transactions. It's outside of government authority, observation, and control. So instead of having to worry about money laundering and these kind of suspicious activity reports and these sort of things occurring, all of a sudden you have this entire ecosystem of transactions occurring outside the purview of any authority. Right? To make matters worse, because this is such a viable business model for these organizations, they've started to outsource and provide a managed service, if you will, really, for customers. So now you have this situation where organizations are publishing code. They have ransomware as a service. Is anybody familiar with Tor and the dark web, right? So, this is their primary mode of distribution, but the reality is that they're pretty open about this stuff. This is not hidden only in the dark web. This is pretty open and accessible to your average kind of script kiddie type individual, right? Which just makes this more and more damaging and dangerous for us as organizations. So again, despite increasing effectiveness, so we've got a lot of tools in our toolbox to try to deal with ransomware. That's part of what we're going to talk about today. But the fact is, they're going to continue to be successful, and they're going to continue to increase in success and the damage that incurs by organizations such as yourselves. And again, you can see this is the frequency will double year over year, up from 2 to 3 million, and this particular statistic was from 2016. And then here over to the side, these are just examples of some of the ransom notes and really just some of the community pages out there for ransomware and the accessibility, again, for the average individual. So just a real quick, kind of how does it work, right? As I mentioned, primarily it started with email campaigns. They're sending out these malicious emails. They've got a payload. They've become quite tricky in hiding these payloads from your average antivirus or intrusion detection system, so that they can get this into the system as the user executes the payload, and then subsequently they hide this on the individual's computer so that it can start encrypting files in the background. right? Interestingly, so I was looking into some of this in more depth. How are these individuals creating these systems to obscure themselves from antivirus services? So they're doing some very nifty things. They're hashing a lot of the files that they're using. References to APIs or API calls are simply references to hashes instead of direct links or direct file names. So again, it becomes harder and harder for your typical antivirus service or protective measures that organizations are employing from finding these either at time of execution or later, right? After they've kind of nestled themselves into the belly of the system, and in theory could wait out for some undisclosed period of time before they ultimately execute and start to encrypt files, either on the individual's computer, or in this situation, where they can start to spread throughout your network. So as I mentioned earlier, WannaCry and NotPetya really kind of changed the game for malicious code with respect to ransomware because it was able to spread so broadly. The National Health Services in Great Britain, they were hugely impacted by WannaCry and this ability to spread so quickly. Interestingly, so now they're morphing even more. So there's a new type of ransomware out there called SamSam. There's one Samus, I believe is the name. That also, what it does is it's a multi-pronged attack in the sense that they're trying to gain access through typical exploit methodologies outside of the email execution threat vector, then start to use tools such as Active Directory to crawl your network, identify assets of high value, right? So it's not just a random, let me just throw this to the wind and see what I encrypt. Now I'm going to actually start to do some engineering work and start to look at the assets on your network and start to target them specifically and encrypt those because they're high value assets, right? Curiosity, so does anybody have any idea, what is the primary group or industry, let me say industry, that ends up being the kind of brunt of ransomware attacks? No, the industry that's the brunt. What's that? Healthcare. Whoever said healthcare. Healthcare makes up half of these attacks. And then, of course, government entities are kind of the next. And the reality is it's because their data is so valuable, right? I think that these groups understand, again, as they mature and they morph over time to say, look, those, and I think somebody said it at the very outset, that those organizations are more likely to just pay the ransom because it's patient data, health, lives are, and health of patients is at risk. And so they're willing to outlay that, that money to get that data back as soon as they can, right? So the reality is as it spreads through the network, it encrypts the files. Again, they are getting better and better at this. Instead of encrypting all the files at once and presenting the user with a ransom note immediately, they kind of secretly encrypt files behind the scenes. They're very targeted in the type of files that they encrypt so that the system remains functional. They make sure that they download randomized encryption keys from specific sources on the internet. There are all sorts of tricks that they're employing to make these attacks not only more effective, but as I mentioned, harder to detect, harder to prevent, and ultimately harder to resolve, which again is why they make the money that they do, right? So again, typically the user boots up their computer, or in instances of infrastructure, a server is blue screens, crashes, or ultimately reboots. They're presented with a ransom note, and subsequently they have to either go through the process of trying to remediate that and mitigate that, which we'll talk about how DR can play a role in that, or pay the fine. I can tell you, so our CISO, our Chief Security Officer, who I work with very closely, has kind of been in this mode of understanding how ransomware works and how customers of ours have been impacted in the past, and most people just paid the fine. And if you go to the FBI, or not the fine, the ransom, the FBI will even tell you, look, pay the ransom, because there's just not much you can do unless you have good backups or good DR planning and an ability to recover to get that data back. It's lost. And I would note that, interestingly, some of these ransomware attacks now are going to the point where they don't even bother trying to provide you a recovery mechanism. They just figure you'll pay, and then they walk away. Thanatos is another variant that came out not too long ago, and it does exactly that. It creates all these randomized encryption keys, and then it just doesn't bother to save them. And so you have no ability to recover your data whether you pay the ransom or not. So recovery from a backup or a DR plan is the only thing you've got. So stopping the infections is obviously primary. We mentioned that that's difficult, right? They make this hard. And you know, what's your weakest link to your network? Exactly. I've been doing this, like I said, for 20 years, and they never surprise me, the things they manage to get themselves into, and how, you know, you think you've created a bulletproof system and then they break it, right? You know, be it security policies or whatever it is. So regardless, you've got to have a multi-pronged approach to stopping the infections. So, you know, kind of from the web and the email and USBs, and bring your own device, which is a much, you know, bigger scenario for organizations today, is really you've got to scan for those vulnerabilities and secure entry points and make sure that you're protecting these assets from the payload in the first place. Who has like email filtering services? I imagine everybody here's got some sort of email filtering service. So that goes a long way to help preventing these things from getting to the users in the first place. The reality is we found that by scanning for vulnerabilities proactively, using the same tools that these organizations use to scan your networks and your systems, is a very effective way of identifying those threat vectors. And then you as an organization can prioritize remediation, right? So users and the IT department and external really is prioritizing patching. I think if we talk again about the WannaCry and the NotPetya's and a lot of these situations, the city of Atlanta and the SamSam situation that they're dealing with, all could have been prevented through a regular patching cadence. Validating that their systems were patched, and that goes back to scanning for vulnerabilities, and making sure that those systems are up to date. We're going to talk a little bit about that. So why do we think, and just curious from the audience here, you know, why isn't it that people are just patching their systems? I mean, it's not particularly hard, right? I mean, most of the software vendors provide you an easy method, if it's Microsoft or you know, some Linux distribution or an application. Don't want to be bothered, that's right. It is time consuming, to be fair. What's that? Well, that's true. There is planned downtime involved, that's right. You've got to reboot. The reality is I think it's also that people are scared of the change and the impact of their systems. They don't have a good method for testing change, and they have no way to automate these things, right? Or if they do, they're fearful of automation and the impact it can have on their systems, right? So we're going to talk a little bit about that, but prioritizing patching, again, based on the evidence in the marketplace, would have prevented a large swath of the attacks and successful ransomware attacks that have occurred. The next is, you know, at the actual individual asset layer, is prioritizing things like alerting and auditing and limiting access, and then firewall policies and the like. But I want to highlight alerting. A big challenge is that a lot of these situations, they didn't know that they had an infection until too late, right? Or they didn't know that they had a system impacted until too late. And why is that? Well, they had no mechanism to observe the health of an individual device, system, or asset, or application stack, so that they could react when that system went down. So, again, it's funny, we as a provider, we work very closely with our customers to work on monitoring, and that's a big part, monitoring and alerting of what we offer, right? It's amazing sometimes that we get into these discussions and these organizations have been running their application stacks and mission critical business applications without any real effective monitoring. They thought they were monitoring them, but they didn't realize that they didn't have true monitoring to understand if their applications were working as designed and that their users could subsequently perform the work that was required. So that's a really critical one. And this is going to play into the idea of alerting, like I said, into actually being able to mitigate an attack, right? Because again, if you don't know it's there, it sits on your network for weeks or months. Recovery from backup becomes less and less of an opportunity for you unless you can lose transactions or whatever work that's been performed over that period of time. So with respect to the DR solutions for testing and patching and upgrades, there's some advantages. Like I mentioned, we find that customers are often reluctant to get too deep in the weeds of trying to automate. They're resistant to patching, not per se because they don't care. It's that, again, they can't deal with the unplanned downtime. They don't know what the impact is going to be to their environment when they apply these patches. While most of the time these updates work, you are going to have those instances where you're running something that creates a blue screen of death, or a process won't start, or a system won't function. So, again, as I mentioned, the majority of these breaches can be directly related to that. So the key is establishing smart patching. Well, this seems obvious and evident, but the reality is that there's some things you can do to utilize tools like Zerto, disaster recovery services, to provide a test bed for you and your teams and the applications that you're running. Who today is using Zerto's kind of failover test in a way not just to validate that your DR is working, but also to run through upgrades or automation testing? Is anybody using it for that purpose today? So we've got one person. Wow, there's a lot of opportunity in the room. That's great. So again, I think the reality is and so I have a team that deals with this. We take full advantage of tools like Ansible. I was actually talking to one of my colleagues today about that. Tools like VRO from VMware and the like. The reality is having a good test bed for that is challenging. Who has a dev test kind of staging environment that they manage for, say, a development team? Right. So challenge with that, just somebody, what are the challenges with keeping an environment like that running? Well, resources is definitely key. What's that? Well, yeah, developers present their own challenge. But the reality is, one, it's production, especially for the developers, right? I mean, you have to be very cautious about what you do with that environment, right? The other is, and this is something I've found as I've had to run these environments for many years, is that it starts to drift. So over time, you instantiate a dev test stage environment. It starts to drift over time. It starts to get farther and farther away from your production environment because it's challenging to refresh all the orgs and refresh all the systems with data. And your developers are screaming at you when you do it because it didn't come back the way they used to have it and they can't proceed, right? Now my QA tests don't work anymore. My scripts don't work anymore. So for an IT kind of back office group, who can't really interrupt that development cycle, Zerto and other DR tools present a unique opportunity to spin up these test failover environments, hold on to them for an afternoon or a day or even a weekend, depending on how much storage you can queue up while you're continuing to replicate in the back end, and test your patches, test your automation, right? Test these orchestration tools that you want to get testing on. It's also, truthfully, an opportunity for staging code from your development teams, right, to make sure that they have an opportunity to test real, production-like. But it's just an interesting note here, and I can attest to this. So, I deal with 43 data centers on a day-to-day basis, an enormous number of systems and servers and switches and routers and so on. This holds very true to me, which is that through 2021, I think this is very true. The single most impactful activity is going to be patching. The reality is we're not good at software. I mean, just in general, it is just bad. You know, it is constantly being updated. I don't know if has anybody heard about the next iteration of the meltdown, Spectre meltdown? I was just getting a debrief on that today. I'm super excited, you know, because I just went through a whole cycle of patches and upgrades and microcode updates and firmware updates twice because they screwed up the first ones. And now I get to do it all again. Right, so really enthused about that. So, but again, and I think 2021 is just, as far as our crystal ball went, I suppose, I see it as kind of an infinite problem unless there's some dramatic changes to the way, you know, code and software is developed. So again, just an opportunity to use the tools at your disposal that you're already investing in and taking advantage of that to actually get some additional value out of them. So, you know, I just wanted to kind of go through a timeline, right? So, you know, there's more traditional DR solutions, typical, I've reserved hardware at a target location, or I've got a target location. This is where I started my IT career. We had a DR site, you know, we tried to buy as like for like as we could, or the last generation of hardware. And the idea was I'm going to restore to it when, you know, stuff hits the fan, as they say, right? The reality is that the time it takes to do that is challenging. So, you know, in a more traditional situation, we've got an infection occurs, right? You know, hopefully you had good alerting. You identified the fact that your systems were impacted and down. You call your provider to get them hey, I need that hardware you promised me. I need that backup or that data replicated to you to start being set up on the servers. The reality is, if I back up, is that with DRaas, and again, all of you are, you know, either current Zerto customers or potential Zerto customers, is that you're able to bring those servers online almost immediately, right? And start getting them back onto a network that's functional. You know, and as I build this out, you know, it's evident the impact of having to go to a more traditional solution versus having a DRaas solution where within 2 hours, I've got my users testing. So this is relevant for the situation with our ransomware attacks in the sense that, you know, once we identify that there's a problem, we can go to our provider or, you know, to our target DR site, spin up these systems, and there's an interesting point here. So let me back up a little bit. What is a challenge around doing this traditional versus DRaas? I think there's one key challenge to this in general, especially when you're dealing with an infection. All right, so that's not leading enough. So the reality is what happens when you replicate the infection, right? So you've got a real problem there. Now, the benefit of a DR solution is kind of we can test, right? That's the thing. We can spin up a test environment, you know, the bubble test or whatever you'd like to call it, the failover test, and validate this checkpoint. No, the infection's still present. This checkpoint, no. And that can be done in a matter of minutes. But with our more traditional method, I mean, I've been through backup restores. They can be painful in their own right. And then, you know, you go through 6 hours of restore to find out that, damn it, you know, that's a bad one. So here I am extending my restore period 6 hours every time I go to check a backup, which, by the way, are 24 hours likely older than the prior, as opposed to DRaas, which is maybe seconds or minutes or whatever. So again, as you're progressing through this, you can see that within 4 hours, you're pretty much back up and running. Users have access to the applications that they need. 24 hours, your typical DRaas solution, you're planning for failback, right? You're planning for recovery back to your primary site. You may not do that, obviously, with ransomware. You want to make sure that you've investigated your network fully. Like I mentioned before, scanning for vulnerabilities is going to be key. You're going to be scanning for malware, scanning for the exploits. Making sure that the home base is clean, if you will, before you start planning on a failback. Unfortunately, with traditional DR, you know, replicated data, you know, you're still dealing with getting them up within 24 hours. 24 hours plus, you're still just validating that your applications are functioning. You haven't even thought about replicating home, right, back to your primary site. So there, again, some interesting challenges that you have to deal with here, especially if something's sat on your network for a while. Is the reality is that you have to be prepared to have checkpoints available to you, especially in the Zerto solution, that can take you far enough back, that you can try to get before the infection occurred. So the challenge there is there's a cost to be incurred here, right? So while a great tool for mitigating a ransomware attack, again, one of the things you have to be prepared for is the cost to be incurred if you're going to retain additional checkpoints. Say, I want to keep one for a day, I want to keep one for 7 days, I want to keep one for 14 days, whatever it may be, that take me far enough back in time that I can get ahead, back to before the infection occurred. Just something to consider is that will obviously have an additional cost to you and your organization from a storage perspective. What's that?
I got a question.
Sure, yeah.
The infection, which has been identified and pinpointed.
Yeah.
Right? It's in software.
Yes.
What happens if the infection is in hardware, such as a cached file?
Yeah, so you've got a bigger problem then, right? From the perspective of hardware, especially if you're talking about like USB-based attacks and those sort of things, Mac has a real problem with that.
Can the infection spread to multiple layers of the network?
It could. I will say that the evidence from a ransomware perspective, they have not matured to that level, and those typical attacks require physical access, right, to systems. Like I said, Mac has a known issue where there's and I can't remember the exact term, but a USB-based attack that is virtually impossible. It basically bricks the hardware because you can't seem to remove it from the firmware. There's just no real mitigation other than it's bricked and you have to replace the device.
Is the application layer most vulnerable to attacks now?
So it's interesting that you asked that. So again, as I was kind of going through and digging into the depths of this, originally it was the operating system layer, right? In the sense that most attacks occurred, it came through email, but the actual exploit was at the OS layer, right? They tricked a user into executing the payload and then subsequently encrypted the operating system. City of Atlanta, they believe it was through a Tomcat exploit. Or a Java stack exploit in publicly accessible web servers hosting applications. So they actually drilled into the environment. And again, it's kind of a two-step attack. They used the web services as an access method to exploit the system and do elevated code execution. The payload that was actually encrypting was kind of a follow-on to that after they identified systems of interest. And that was kind of further to that point. They sniffed the network. They figured out what the valuable assets were before they actually deployed an encryption package. So, like I said, they're getting, craftier and craftier. Was everybody at the keynote this morning at 9? So I thought the conversation was really interesting because if you think about AI, quantum computing kind of plays a different role in this because in theory it breaks encryption, which is a different thing. But this idea that AI is becoming more and more mature, there's this concept of evolving ransomware once it gets into your network. So instead of it being a fairly static payload that comes in today, they can start to use their own access to machine learning, Google tools and all these kind of things to morph their attack over time at the time it's in your network. So it becomes a very complicated problem as AI and machine learning specifically, because these guys are really good. They know what they're doing, and the value is so high. So the key here is really the recovery time. I had to fix that. Recovery time objective, which is 15 minutes potentially recovering and starting to test your apps, even if it's just testing what's good, right? What's my good recovery point or checkpoint versus your traditional DR, which is just not an effective solution. And again, I think that's the problem the city of Atlanta has had. They had a much more traditional solution. They were, and in some instances, it appears no solution at all, right? Because they still have systems that are down, but they did not have a very mature process. I'm running out of time here. So recovery challenges. I think the biggest challenge is that individuals that use a disaster recovery or disaster recovery as a service program don't do a great job of testing it. Who has done a full failover accepting transactions in a DR site? So kind of one. Right. Yeah. But the applications is really the key thing, right? So, can you accept and ingest work into the systems? That's important. And I'll be honest, this is where we find customers frustrated with DR solutions. Is it's claimed to be easy. You press the button, it fails over, everything's going to work. Hey, look, I got a ping, it should be great. No, that's not the case. And so again, as I mentioned earlier, there's a cost to be incurred to that. Most programs or solutions, or even if you're doing it yourself, you're going to have to be able to accept that move of those workloads over to your DR site. But it's critical because the time you need it, you need to know it's going to work, right? So there's the resiliency across all the environments. I'm sure, lots of you still have physical systems, physical workloads that you have to address. There's also getting back to normal, right? If you're going to commit, this failover, you got to be able to replicate back. So you got to be prepared for the complexities of that, depending on, what your ecosystem looks like. And then, of course, there's avoiding the data loss. I think it's always a little bit of a gut wrench when you're failing over and you're pressing the commit, because at that point, you're all in. You're working out of that new environment, and be prepared to sync that data back, right? You can't kind of half-ass it. You got to go and be ready. So just some key, and I know I'm running out of time here, so I'm going to just kind of go through. So some key considerations when selecting a provider, because the reality is if you're going to take advantage of a solution like this, like DRaas and a DR provider, then they've got to have meaningful recovery objectives, right? It's got to be something that's going to work with you as a business. They've got to be diverse. There is, unfortunately, right now, no one-size-fits-all from a DR solution unless you are 100% virtualized. We see that occasionally, but it is rare, right? Usually somebody's got some other solution set, physical server somewhere, some old Unix box, a mid-range. I used to manage iSeries environments, so we were always trying to deal with LPARs and these fun, happy things. So you want a provider. They've got the 24/7 support. That goes back to alerting. If you're going to have a problem, you want to find it and see it right away. Right? And the reality is small businesses or even enterprises, a lot of them don't have 24/7. They're not watching the screen all day long, right? So, and then a provider with an experienced reputation, somebody who's going to help you with their consulting services, and then the testing procedures. I mentioned that already. You've got to have robust testing procedures. And then ultimately compliance, expertise, and certifications. Who is using today their DR solution for compliance and reporting compliance? Yes, we got a couple. So that's becoming more and more prevalent. I mean, I think more and more businesses are fitting into very specific compliance and compliance regulations. There's PCI, there's GLB, SOC, FISMA, there's all sorts of things. The reality is that a solution specifically like Zerto should help you in that endeavor. In theory, not only are you proving compliance, but you're also validating your tests, validating your test environment, your DR environment, and subsequently the idea is being compliant should in turn make you more secure. I don't know that that's necessarily 100% true. You still have to be very diligent, even if you're just showing compliance and going above and beyond that, but it is an important first step, right? And then I'll leave you with TierPoint. So I mentioned, we as a provider offer a very diverse set of DRaas solutions. It could be software as a service, hyperscale, very mature DR with hypervisors specifically. Physical, in fact, when I started in this industry, we were primarily doing physical, even though a lot of the world is moving to virtual. In general, virtualizing their data centers, you kind of started with that physical DR solution and had great success there and subsequently expand it. The reality is that, we can kind of take in as a DR target, customers that want to utilize our services in our 43 data centers, or we can help facilitate them getting into the hyperscalers. I don't know did anybody go to any of the Azure sessions that were here today? So, there's a lot going on in that space. I think there's still a lot of uncertainty. There were a lot of good questions during that, but, TierPoint is making real strides in kind of helping our clients understand the ins and outs of the various solutions, be they coming to our environment or one of the hyperscalers. So, look at that, 5 minutes to spare. I knew I was between you guys and beer 30, so I was going to try to wrap this up on time. So, questions? Thoughts on ransomware in general? I don't know, this whole thing kind of got me freaked out, so I've been spending a lot more time researching this. It is an accelerating problem, so, yeah.
So one of the, I think, most difficult parts of when such a recovery is usually to have all the data consistent.
Yeah.
What is the solution for that? How does Zerto approach that? Recovering all the data in a consistent way.
Well, so, yeah. Right. So there are some challenges there, right? And that, again, comes into kind of a full-tiered solution, right? And that was one of the challenges on the challenges slide. It's very good at crash consistency. It is challenged with respect to application consistency with things like databases. The important thing there is taking advantage of all the tools in your tool belt, SQL mirroring, right? Log journaling, all of those kind of things to make sure that you have an application consistent environment as well as a crash consistent one. So, but I don't, again, as I mentioned earlier, there's not really an all size fits all, or one size fits all kind of solution for DR. And so we run into this. We have customers that have very specific use case requirements around Oracle RAC, or SQL Server. So we work with them to either exclude those systems from, say, a solution like Zerto and do a very specific replication partnership, or we tend to do the operating system layer of those systems and then exclude the databases, and then we'll take advantage of an alternative solution. It's not as clean. It requires a little more hands-on investment because you've got to be able to fail over a SQL cluster or a mirror, right? But it's the right way to do it. So, good question, though. Anything else? All right. Well, thank you guys so much. I appreciate the time. You guys enjoy the rest of the conference.